Welcome back to the channel and welcome back to this Levitator project, which I've had to return to because of that ugly mess. That's what I'm going to change, and also because it seems to be quite a popular series. I mean, if you look at this blue line there, evidently you folks like this, so I think that it's only right that I should finish the project properly, and we'll end up with a wireless electric levitator that doesn't have that circuit on the end. It'll be far simpler than using one. Also, I'll be showing different amounts of turns on the receiving coils and which one works the best, because we do have to factor in weight as a consideration. So first of all, here is the system running as it is at the moment with the horrible circuit on the right hand side. You can see that the blue LED is nice and bright. I'll let you know more about that later on. The current usage is 110. At 120 milliamps. So that's what we're looking at replicating by changing that circuit to something a lot better. So first of all, I'll take this one off, and I think I know which route to go, and we'll find out if that's the way. There we are, the big chunky circuit is removed, and all we've got left is the transistor and a couple of resistors, and they go to the coil that you can see underneath the main Levitator coil. And the reason why I'm doing this is because if you stick to around 1.5 volts and about say 20 or 30 milliamps, everything runs fine. And above that you start introducing heat issues for no point. There's no extra wireless range, no extra distance available or power output. So what I'm aiming to do is to use different resistors and probably a diode and see if we can get things under control without needing such a big chunky circuit as that. It should be simple, but it wasn't earlier, and that's what I'm fixing. And so after some experimenting, here's what I've come up with that I'll put onto a board in a few moments. But yeah, two resistors, a diode, and that's really it, apart from the transistor to the coil. So I'll show you the circuit diagram of this change now. And the next thing I'll do is to put these pieces onto a piece of Vero board and neaten the whole thing up. There it is, very simple indeed with its inputs and outputs. It looks a lot better than the prototype version over there. But the next thing to do is to put the wires on, and then I'll probably put it at the front here. And that's why I did make it thin in the first case, thinking about mounting it to that part there. Here we are with the first test. You can see that the light is very nicely bright indeed. There's the circuit yet to be finished off, and we're right down to about 50 milliamps. So in fact it saved quite a lot of input power as well. Next thing I'm going to do is to just get that glued onto there, tidy these wires up, and then I'll just quickly explain the reasoning for the amount of turns on the coil. There we are, all neatened up, and at the moment it's levitating a 96 turn coil. I got 96 turns on there because the wire I'm using is 38 AWG. You can see the size of my finger and perhaps the tiny thin wire that I've been using. Behind is a 24 and a 36 and a 48. So here's a 24 turn, which you can't really see anything coming from that green LED. There's a 36, which, yes, it's okay, that red is on, but it's not bright enough. And this is a 48 that really squashed down the coil while it was drying, and it's rubbish. I mean, it's really good. When it's close, it's fine, but not when it's suspended away underneath the coil. So here's the main Levitator circuit, which somebody did point out is actually in suspension rather than levitation, being as objects are being held from above. But I think it's common enough parlance to call it a levitator. A very simple circuit here with the LM358 being used as a comparator. And you use the small pot to adjust the distance to get the levitation or the suspension to happen. And here again we have the wireless electricity section. Very, very simple, and all that happened really was I forgot that trick from years ago about using a simple diode, in this case a 1N4148, they're rated at 200 milliamps, and that really does help to keep a transistor cooler. There's no heat at all now, so it's a very, very good improvement. And there we are, back to the 96 turns. Well, I hope you've enjoyed this little journey, and if you have, please do consider subscribing. I'm trying to get to 1,000 subscribers and 4,000 watch hours and get finally monetized. So thank you very much for watching. Good luck with making your own if you do, and see you next time.